Bismillahirrahmanirrahim. Assalamu alaikum, students, boys and girls, and good morning. Uh, Let us start the new and fresh chapter from this book. Got it? So, let me start the topic which we are discussing, and that was lines, angles, and shapes. Now, let me start from the very first word, and that is line. We have already studied the line. It is a line and it has no ends, unless and until we mark some point on it. This segment is a line segment called, and it is named as AB. Now you see that this is a single line. We have started from the single line. Now what we did in the angles was we took another line and fixed it at one point and keep on rotating it at this second point. So it became an angle. Now, my dear students, now these were two lines, and if I do not fix this one point, this one end, which was called vertex in the angles, what we did that we draw two lines and give a hint to you that these are parallel lines, because this arrowhead means that this is a parallel line. So these are the parallel lines, and don't show any characteristics unless and until we intersect it with the transversal. We intersect it with the transversal. Now there are some angles formed which were called F angles, Z angles, and C angles. You know it very well, and we have done some exercises on this. So today we have done this, and today we are going to start with the first shape, and that is line. A shape consisting of three lines. And this is like this. You see, what is formed? A triangle. Now let me do it in detail. Now, dear students, you see that I have drawn three figures on the whiteboard, and I am going to tell you about the characteristics of these three triangles, but with respect to their sides. Now we can classify the triangles in two main classifications, and that are: number one, with respect to their sides. Now this is with respect to their sides. WRT sides. With respect to their sides. Now what does it mean? That first of all, now this is figure 1, A, or whatsoever it is. Now in this triangle, if we are studying with respect to sides, now let us consider that all the sides of the triangle, this is angle X, this is angle Y, and this is angle Z. With respect to their sides, figure A. Now in this triangle, you see that if I say that this side is, let us say that this size is 30 centimeters, this side is 35 centimeters, and this side is 32 centimeters. Now you see, my dear students, that all the sides of this triangle are different. When all the sides of the triangle are different, that means in their length. Now this is, let us say, 30 centimeter, this is 35 centimeter, and this is 32 centimeters. Then their angle are also equal. Then their angles are also different. X is not equal to y, and y is not equal to z. Z is not equal to x. So these all are different. That means with respect to their sides, when we say that all sides and all angles are unequal or different, then we call it scalene triangle. Then what we call it is as scalene triangle. Now this is a scalene triangle. What is it? This is a scalene triangle. The other triangle is this, and these two short lines indicates that this side is equal to this side. For example, this side is 32 centimeter, this is also 32 centimeter, and when there are two sides equal, then the base angles, you see, these are the base angles, the base angles are also equal, must be also equal. Now this is, if this is x, this is also x, and this is y. This is 32 centimeter, for example, this is 32 centimeter, then this is also 32 centimeter, and the base angles is x and y. Then this triangle is said to be isosceles triangle. What is it said? It is said to be isosceles triangle. Isosceles triangle. Scalene triangle, isosceles triangle. Neither side is equal, nor angles are equal. Two sides are equal, two angles are equal. Isosceles angle, isosceles triangle, and the third and the last is equilateral triangle. The third and the last is the equilateral triangle when all sides are in. Now this short line tells us that this line is equal to this line is equal to this line. That means if it is 35 centimeter, this is also 35 centimeter, and this is also 35 centimeter. When this happens to a triangle, then their angles are always 60 degree. They are not only equal, but they are only and only 60 degree. There is no other triangle which is an equilateral triangle and have angles greater than or less than 60 degree. You followed my point? There is no other triangle which is said to be equilateral and has the angle of 55 degree. No, it is not possible. The only and only triangle which is equilateral triangle will consist of 60 degree angles each. Now dear students, let me recap. The first triangle, fig A, fig B and fig C. Now in the first fig A, the sides and the angles are different. No side is equal, no angles are equal. So it is said to be scalene triangle. In the fig B, you can see that two sides of this triangle are equal, and the base angles, it is also called base angle, and you can also call it as, or the base angles are also equal. It is x, it is x. Okay, it is said to be isosceles triangle. And when all the three sides are equal, when all the three sides are equal, this is centimeter, don't confuse it with, this is board, so this is centimeter. You see that this consists of 30 centimeters. All the three sides and all the three angles are equal, and the only angle is 60-degree, which is an equilateral triangle. Now this is an equilateral triangle. Now these are the three kinds of triangle with respect to their sides, and we have already uh, studied the triangles with respect to their angles. Just recap them for your knowledge, and that are acute angle triangle, right angle triangle, and obtuse angle triangle. We have already studied that. Before rubbing this, I may tell you that in every triangle, whatsoever the triangle may be, it is a scalene triangle, isosceles triangle, an equilateral triangle. The sum of the angles in this, x plus y plus z is equal to 180-degree. In this, x plus y is equal to 180-degree. And you can see with the naked eye that 3 multiplied x, 3 multiplied 60 is 180-degree again. Now this is 3 multiplied 60 is equal to 180-degree again. That means then if the triangle, take a triangle, any triangle with respect to its sides or with respect to its angle, the sum of their angle will be 180 degree. The sum of their angle will be 180 degree. The sum of their angle will be 180. Okay, so this is a very special point that should be remembered for forever. So let me rub it and we'll draw another three triangles. Now the triangles with respect to their angles. Triangles with respect to their angles. With respect to their angles. We have already touched this topic, but to recap, now there was a triangle which was acute triangle. I am going to just draw it like this in freehand. Now this is an acute angle triangle. Now what are the characteristics of this acute angle triangle? The acute angle, all the angles in this triangles are less than 90 degree, are less than 90 degree. That means A is less than 90 degree, angle A is less than 90 degree, angle B is less than 90 degree, and angle C is also less than 90 degree. All the three angles are less than 90 degree. When this characteristics appears in one triangle, that means that this is acute angled triangle. Now let me draw a right angled triangle. Now this is a right angled triangle. Now this could be a scalene triangle. Now this could be an isosceles triangle. Could be. I am using the word could be. Now this also be equilateral triangle. Now you see that all the angles are of 60 degree. All the angles of 60 degree. Then the equilateral triangle is also an acute angled triangle. Now, if one of the angle in a triangle of one of the angle in a triangle is equal to 90 degree, is equal to 90 degree. One angle is, that is A angle A is equal to 90 degree. You see that only one angle can be 90 degree. There cannot two angles in one triangle cannot exist equal to 90 degree. There will be one angle only that will be equal to 90 degree. No other angle in a triangle could be 90 degree. One angle only could be 90 degree in a triangle. The We are not concerned with the other two angles. So if this happens, if this characteristic is appear, then we say that this is a right angled triangle. Right angled triangle. And there is one another obtuse angle triangle. Obtuse angle triangle. You know that obtuse angle triangle has one angle. Now this was, let us say that this was 90 degree. Now it has gone beyond 90 degree. It has gone beyond 90 degree. This was 90 degree. It has gone beyond 90 degree. So one angle, if one angle that may be is greater than 90 degree, if one angle is greater than 90 degree, then the triangle is said to be obtused angled triangle. Obtused angled triangle. Now this was the main classification of the 6 triangles that were with respect to their sides and angles, that were scalene triangle, isosceles triangle, and equilateral triangle. And with respect to their angles only is acute angled triangle. All the angles are less than 90 degree. And right angled triangle, only one angle can exist in one triangle that is equal to 90 degree. Two angle cannot exist in one triangle equal to 90 degree. So one angle is equal to, if one angle is equal to 90 degree or right angle, it is said to be right angled triangle. If the angles are greater than, if one of the angle is greater than 90 degree, if one of the angle is greater than 90 degree, then the triangle is said to be obtuse angled triangle. Well students, as I told you that a triangle, the angles between the triangle, there are three angles, you know, that A, B, C. In this triangle A, B, C, A, B and C, there are 3 vertices and 3 angles, and the sum of all the 3 angles is 180 degree. That was one thing that I told you. Now the other thing is that if I break these angles, what I said is that the sum of the 3 angles is 180 degree. Now one thing strike to my mind, and what is it? That is, if I break this triangle, break these angles from here, let me break. Okay, this is broken now. Okay, let me separate it from here. Let me separate this angle also from here, and let me separate this angle from here as well. Now you see all the three angles are broken. This one, and this one. Now what I am going to do? Just take a look on this, that if I join these angles together, if I join these angles together like this is angle A, this is angle A, this is angle B, and this is angle C. We have been told that if we add up these angles, then it will come as 180 degree. The sum of all the angles is equal to 180 degree. Now, one more thing comes to my mind, that if this angle plus this angle, or this angle plus this angle, that if all the three angles are 180 degree, then it means that the sum of two angles be the supplementary of one other angle, and that you can see it if I extend it from here. If I extend this line from here, then this angle B and this angle C. Now this angle B will lie over here. Now the position of the figure will be like this. Now this is angle A and this is angle B and this is angle C. That means, now what do we conclude from this broken triangle? You see that now this angle B is over here, angle C is over here. Okay. Now that means that there is one angle A over here, which I already written, and there is one angle outside this angle, that is A, B, and let me call it as D, and I am going to write it in small. Now you see that if I add these two angles, it will be equal to this exterior angle, because you see that A is there. Now A is there, and the sum of B and C should make 180 degree. A, B, C should make 180 degree. A is already there. A is already there, and B and C should make, including A. Yes, including A. B and C including A should make 180 degree. Now it does mean that this B and C plus A. Let me separate these B and C. This is B and this is C. Now this B and C are the angles which, if added to A, will give us 180 degree. So it means that, now look at this figure very carefully. This is angle A and this is angle D. Now it does mean, just to repeat my words, that B plus C plus A gives us 180 degree. So it means that B angle C angle is equal to D angle. Got my point or not? That B plus C, that B plus C is equal to D. Now these are the two interior angles. These are the two interior angles, and D is the angle opposite to C and B. D is the angle opposite to B and C and is exterior angle. Opposite exterior angle. Exterior angle. Now this is one hypothesis. This is one proof that the sum of two interior angle is equal to the one sum of two angle is equal to the one opposite exterior angle. One opposite exterior angle. If I now take A and B angle as the interior angles, A and B as the interior angles, now there is an angle which is D and now it is E. Now this angle is E. Now this E angle is the exterior angle and is opposite to A and angle B. Exterior angle E is opposite to A and angle B. Now if I add this A plus B, A plus B, that must be equal to C, okay? It is confirmed. But you know that this E is supplementary to this C angle is supplementary to this E angle. Now this is interior angle and this is exterior angle. So that now the combination of two, the sum of two C and E angle is 180 degree. And if I exclude this angle, I take this angle B and A, that means only which angle is left? C. So that means A and B should be equal to this E angle to make it 180 degree. To make it 180 degree. So it is common property that when you take two interior angles, the angle opposite to the two interior angles and should be exterior, that will be equal to the sum of two interior angles. The sum of two interior angle is equal to, or you can say that sum of two interior angles, the sum of two interior angles is equal to one opposite exterior angle. Now this opposite word is very necessary. It is essential. It is very essential. You see that here what we did, we add this which was equal to this, B plus C is equal to D, okay, and A plus B is equal to E. Now A plus B, where I write A plus B is equal to E. So these both are the interior angles and opposite to them exterior angle is E. Now dear students, let me prove the both hypotheses which I told you. Number one, and that is the sum of two interior angles of a triangle is equal to the opposite exterior angle, and the other hypothesis was that the sum of all the three angles is equal to 180 degree. So it is very easy to prove that. We have to prove that the sum of A, B, C is equal to 180 degree. Meanwhile, I have just told you how I converted these broken pieces into 180 degree. That was okay, that was one method to prove it. But logically, how will you prove it? And I will prove it like this. We have drawn a triangle. We have drawn also a line parallel to BC angle, or you can say that A with angle A, B with angle B, and C with angle C. Now this line, the red line, is parallel to this BC line. Okay, it is very easy. Now when this line EF is parallel to this line, and this is a transversal AB, you may notice that X is equal to C and Y is equal to B, because both are alternate Z angles. Alternate Z angles. You can see a good Z over here. Now you can see a Z over here and a Z over here, and this is angle X, and this is angle B, this is angle Y, and this is angle C. So these angles are equal. Since these angles are equal, now this line measures 180 degree. This line measures 180 degree. So that means X plus A plus Y, X plus A plus Y, X plus A plus Y is equal to 180 degree. And if I substitute their values of X and Y, I remove X from here, I remove Y from here, I just substitute this value with the value of the angles. Now this X is equal to B, this X is equal to B, this Y is equal to C, as I get drawn over here. So I can substitute the value of X with B. I can substitute the value of Y with C. A will remain there, and substitute the value of Y with C, and that is equal to 180 degree. So what is the conclusion? A, B, C is equal to 100 degree. So it is proved that the sum of interior angles of a triangle is always equal to 180 degree. And in the triangle, equilateral triangle, we have seen it that all the angles were 60 degree. You see that all the angles were 60 degree. So if you add them, it will give you 180 degree. Now dear students, what I told you about the property, first property of the triangle, that the sum of two interior angle is equal to the one exterior angle opposite to them. Now I have taken only one, because when one is proved, every other is proved. So what we have to prove is the exterior angle X. The exterior angle X is equal to A plus B is equal to A plus B. It is very simple, and it is hypothesis, and we have to prove it. And with the proof, we have to accept the hypothesis, or we have to reject the hypothesis. So the exterior angle X is equal to A plus B, so that we prove it.
Now you see that this is line. Okay, this is line. Let me mark it A, C, D. Now this is line A, C, D. Now in this line ACD or AD, simply call it AD. There are angles supplementary. You can see the supplementary angles over here. That x plus c is equal to 180 because they are formed in one line. And I have told you earlier that when there are angles on line, they are supplementary. Either they are 2 or 3. Now this is angle A and angle B. Angle A plus B is equal to 180 degrees. That I have told you earlier in my previous lectures, somewhere in my previous lecture. Now we can easily eliminate this x from here and we can put this x over here. C is equal to 180 minus x. Simple algebraic method. And A plus B plus C, A plus B plus C is equal to 180 degrees. This we know that from the previous proof. From the previous proof, yes. Prior to this proof, what I proved was the interior angles are equal to previous proof. That was sum of the angles of triangle is equal to 180 degrees. Now this is reason. Argument. You can also say it argument. Okay. Now this is A plus B plus C is equal to, the argument or the reason is the sum of the interior angles of triangle is 180 degrees, which we have already proved in our previous hypothesis. Now we know that A plus B plus C. Now if I manipulate this C with this one, now what we do here, we just find C also from here and we'll eliminate this A plus B from here. Now C is equal to 180 minus A plus B. Now you see, my dear students, that we have two terms that are equal to C. C is equal to 180 minus X. C is equal to 180 minus A plus B. Okay, then we compare the both. When two things are equal to C, now two right hand sides are equal to C, then we can easily compare that this right hand side is equal to this right hand side. Got my point or not? By comparing equation 1, now this is, let me number it, equation 1, equation 2. By comparing now the reason or argument is by comparing is, I can do it here somewhere because I know that if I go below this line, it will not be visible to you. C is equal to 180 minus X, C is equal to 180. So let me write both right hand sides, because we have to compare them. And we know that both right hand sides are equal to C. So 180 minus X is equal to 180 minus A plus B. Okay, now Now there's some interesting things coming up over here. Hundred it is at this side of the equation, 100 it is at this side of the equation. Both are positive, we can easily cancel them. Both quantities, both magnitudes are equal. We can cancel them because this is left hand side and this is right hand side. 100 it is over here, 100 it is over here. So we can cancel them, and we can also cancel the remaining sign. The remaining sign is minus, so we also cancel this remaining sign over from here. So what is left behind is x is equal to a plus b. X is equal to a plus b. And where is x? This is x. And where are a plus a and b? Now this is a and this is b. Though it is proved that. Now here you can see the proof with your naked eyes that a plus b are the interior angles of the triangle, and the opposite exterior angle is x. Opposite interior angle is x. So x is equal to a plus b, and so we should accept the hypothesis, and that was the sum of two interior angle of to prove the exterior angle x. So what was the hypothesis? The exterior angle x is equal to a plus b is equal to a plus b. So it is proved, and we have to accept the hypothesis. So hypothesis accepted. Hypothesis has been accepted and it has been proved. And what we write here, QED. What does it stand for? This is your homework. So my dear students, these were the two properties of triangles which I have not only told you in detail but also proved them in front of you. So it's time to say goodbye. Allah Hafiz.